Hello everyone. Note down this question. There are two ice bullets. Bullets made of ice of mass m each are moving with speed v. Both are moving with same velocity v, same speed v, such that it's a perfectly inelastic collision. If latent heat of ice water system is L, then find out after collision how much ice in total melts. For a perfectly inelastic collision, write down the question. For a perfectly inelastic collision, how much ice melts? There are two ice bullets and they are moving with speed v. A collision takes place which is perfectly inelastic. And then the question is that if latent heat of ice water is L, then how much ice melts? There are two ice bullets approaching each other with same speed v, having mass m. For a perfectly inelastic collision, how much ice is going to melt if latent heat for ice water system is L? Not a single response. So when you say perfectly inelastic collision, that means E is 0. Perfectly inelastic collision, E is 0. This question is basically how do you mix two concepts from different chapters. Concept which you have from the collision and all, or do we use along with the concept of latent heat? Then only you can answer the question. So once I say perfectly inelastic, that means E is 0. Then try to find velocity after the collision. With what velocity these bullets are moving after the collision. Let's see how many of you can answer this. Try to answer this part. With what velocity, with what speed these bullets are moving after the collision. We got no response. Once I say that E is 0, what was this E? This E was V2 minus V1 upon U2 minus U1. We used to write this thing as minus of E. I remember this formula. V2 minus V1 upon U2 minus U1, that was what? Minus of E. If E is 0, then it immediately tells you that V1 is equal to V2. V2 minus V1 upon U2 minus U1 is minus of E, but E is 0 because it's a perfectly inelastic collision. And that gives us E0 means V2 equals V1. So these bullets are moving with same speed. If they're moving with same speed, then simple logic tells us they are identical bullets, MM, VV. If they are moving with same speed, and I say that bullets are moving in this direction, then you will ask, what is special about this? Why can't they move in this direction? Because this is M moving with V, this is M moving with V, and they both are identical ice bullets. So, they should move in this direction or they should move in this direction. No, they should not. Because they are identical bullets, but their speed should be same. The only thing left is what? V1 equals to V2. Logic says is what? 0. Or you could have used concept of COLM, conservation of linear momentum. COLM. When we talk about collisions, we also use, apart from this Newton's equation, we also use the concept of COLM. What is COLM? M1 U1 plus M2 U2. What is that? Minus of V. Linear momentum is a vector quantity. Finally, M is moving with V1 and the other M is moving with V2. But we know that V1 and V2 are what? Same. So if V1 and V2 are same, this part is what? 0. So it gives you 2M V final. V1 is equal to V2. And let's say this is V final. If this is V final, it gives you this. That means V final is coming what? 0. Now if I say that V final is 0, that means what? That means this. What was initial kinetic energy? What was initial kinetic energy of the system? Half mv square, and there are two such bullets, half mv square and half mv square. What is final kinetic energy? Final kinetic energy is what? 0. K initial half mv square plus half mv square, and finally they both come at rest 0. That means what? We have lost this much energy because of the collision. As this collision takes place, these bullets, they come to rest. And if they come to rest, they have lost all of this kinetic energy. Then where does this energy go? This energy is going to melt the ice present in the system. And when ice melts, what we do? We say that if m dash mass of ice melts, latent heat is what? L, n dash L. Question is looking for what? After perfectly inelastic collision, how much ice melts? The question basically says find out n dash. To melt m dash amount of ice, you need some energy, and that energy is coming from this mv square. mv square, which gives us m dash as mv square divided by L. Basically, this question should take only this much time, that is about 10 seconds. If I say it's a perfectly inelastic collision and you find that both bullets are moving with same speed, then ultimately they come to rest. If they come to rest, then loss in kinetic energy is half mv square multiplied by 2, and the entire loss is available for what? As a heat source. This is the source. What is the source? What is the same? The ice which is going to melt. If you have understood this question completely, then write down yes in the comment box and note down everything. Write down thermal expansion. What is thermal expansion? Everybody knows about these things, at least the overall behavior. If we have a rod and you increase the temperature, length of the rod is L. If you increase the temperature, then its length is going to increase. If you have a disc you increase the temperature, its area is going to increase. If you have a cube, solid cube, if you increase the temperature, its volume is going to increase. Increase the temperature, length of the rod will increase. Increase the temperature, surface area is going to increase. Increase the temperature, volume occupied by a solid body is going to increase. So this is something which everybody already knows about. This is called your linear expansion. This is surface expansion. And this is volume expansion. Linear for the length, surface for the area, volume, you know about it. Now, what is observed? That change in length from L, let's say this much length, this L increases by this much. By how much? By delta L. When length is L, temperature was T. When length becomes L plus delta L, your temperature is now T plus delta T. So initially you have a length of L, and then when you increase the temperature by delta T, your entire length becomes what? L plus delta L. What is observed that this change in length divided by original length delta L upon L is proportional to change in temperature. Delta L upon L is proportional to delta T, change in the temperature. Similarly, for the surface, it is observed that change in the area divided by area is proportional to delta T, change in the temperature, and for the cube or any solid body, change in volume divided by original volume, initial volume, is proportional to same change in the temperature. When we remove these proportionality signs, we say that this delta L upon L is alpha into delta T. And this is proportionality sign and this is alpha. So delta L upon L is what? Alpha times delta T. This delta A upon A, we write it as beta into delta T. Delta A upon A, remove the proportionality sign and then write beta delta T. Alpha beta, you know what is to come over here. So when I write delta V upon V, this is gamma times delta T. Alpha, beta, gamma. This alpha is coefficient of linear expansion. Beta is coefficient of surface expansion and gamma is coefficient of volume expansion. These are constants for a given type of material. We'll write this statement, but note down everything. This for linear part, surface and the volume thing. First this and then this and then this. Note down this much. Write down the statement. When a rod of length L, at temperature T is heated such that its length increases by delta L and temperature increases by delta T, then it is found that change in length per unit length per unit change in temperature per unit change in temperature is a constant. What did I say? Change in length per unit length per unit change in temperature is a constant. And this constant is what? Alpha. This constant is called alpha, which is also called coefficient of linear expansion, which is also called coefficient of linear expansion, and is a constant for a given type of material, and is a constant for given type of material. Now you can write the same thing with surface and the volume. Change in the area divided by area per unit change in temperature is a constant, which is beta. Coefficient of surface expansion, coefficient of volume expansion, which is gamma. So you can do that if somebody is interested, or I hope you are comfortable with this part itself. Now, we can always find a relationship between alpha, beta, and gamma. How do we do that? Look here. Or, in fact, just imagine, I'm giving you a hint and I hope you can figure out yourself a relationship between alpha and beta and gamma. Let's talk about alpha and beta, and I'm giving you the hint. This is a rod. Now, this rod, now consider a rectangle. If you consider a rectangle, it has two sides. If you increase the temperature, both sides are going to increase. What are sides? Sides are what? Linear. And when you take care of both sides together, when you multiply them, you will get what? The area. So this way, you can easily figure out relationship between alpha and beta. And then we can do the same thing with a cube also, or a cuboid. So I'm giving you around 30-40 seconds. Find out, write down the question, find out relationship between alpha and beta. Find out relationship between alpha and beta, and once you get that, write that in the comment box. Let's see how many of you can. Only 2 responses. Look here. Suppose we have a rectangular plate with side lengths A and B, and temperature is what? T. Then when temperature is increased by delta T, from T you increase by delta T, it becomes T plus delta T. We found that this length is now A plus delta A, and this length is B plus delta B. Delta A, change in length. Delta B is also what? Change in length. What is the initial area? A into B. What is final area? A plus delta A multiplied by B plus delta B. It's a rectangle, simply multiply both sides and you got the area. This area is coming AB plus A delta A, sorry, A into delta B AB, A into delta B plus delta AB plus delta A multiplied by delta B. AB, A delta B, delta AB, delta A multiplied by delta B. Now, we have done things like these before. If you have something like dx plus dy plus dx multiplied by dy, if you have a setup like this, then we say that this term is almost zero as compared to these two. dx पहले से ही क्या है, बहुत छोटा, dy यही बहुत छोटा number, and if you multiply dx and dy, then this thing becomes what? Much smaller. For example, if I say take dx as 10 to the power minus 10, dy also as 10 to the power minus 10, then dx dy is nothing but 10 to the power minus 20, which is what? 10 to the power minus 20, you can say almost is what? 0. So this is almost 0. We can do what? Saying delta A and delta B, they are kind of what? Negligible as compared to these terms delta B and delta A. Remember, this is delta A multiplied by B. This is not delta of AB. Or did we get this term? This is delta A multiplied by B. To avoid any confusion, write down in fact this way. Delta A multiplied by B. To avoid any confusion, let's write down this thing as B multiplied by delta A. So, this is your dx, this is your dy, and this is what dx into dy, which is what? Almost negligible. This gives us AB. What is AB? A initial. What is AB? A initial. This A initial has two things. What? A delta B this AB is A initial plus A delta B plus B delta A, and this part is almost what? 0 because of that logic. This term is approximately what? 0. Forget about this term. Now, if this is 0, almost 0, then what is this? A final. What is this? A initial. So we can write delta A. What is delta A? A final minus A initial. A final minus A initial is A into delta B plus B into delta A. Now, look here. What is delta A divided by A? Basically, we are interested in what? Change in area upon area. So, delta A upon A is A delta B divided by A. So, when I say A, this is A. A initial will be called what? A. Initial area is A. Delta A upon A is this AB plus B delta A divided by AB. Now, delta A upon A divide the whole thing with delta T. Delta A divided by A, divide also by delta T. This is what? A and A cancelled. Delta B upon B, divide also with delta T. Delta A, B and B cancelled. Delta A divided by A, also have the term of delta T. Now, what is this? Change in area per unit area per unit change in temperature, which was called beta. This thing was called what? Beta. What is this delta B? Change in length per unit change in temperature, which was called what? Alpha. Change in length per unit change in temperature, which is also what? Alpha. This gives us beta is 2 alpha. Coefficient of surface expansion is double of the coefficient of linear expansion. If you have understood the derivation, then write down yes in the comment box and note down everything. Now, we have found a relationship between beta and alpha. I'm giving you about 1 minute's time. Take a cuboid of side length A, B and C. This is a plate with sides A and B. Now take a cuboid with side lengths A, B and C. Use the same concept, same technique, and then find out relationship between alpha and gamma, coefficient of volume expansion. Same method. We have found change in area, over there found change in area, and try to eliminate things like these, and hopefully you can answer this in just 1 minute's time. Let's see how many of you can find a relation between alpha and gamma. Once you find it, write that down in the comment box. Good, that's the correct result. And those of you who could not, look here. We have the cube. It's a solid cube, remember, with side lengths A, B and C, and the whole thing has a temperature of T. The cube is at temperature T, and then what you did, you increase the temperature and then it becomes, it's like this. Slightly larger. temperature is T plus delta T. This side becomes A plus delta A. This becomes B plus delta B, and this becomes C plus delta C. So your solid cube, when you raise the temperature by delta T, that's how it looks. Now we know that delta A upon A delta T, delta B upon B delta T, delta C upon C delta T, they all are same. For a given material, change in length per unit change in temperature is a constant which was called alpha. Now, what is V? We'll call it initial volume, A, B, C. What is V final? V final is A plus delta A multiplied by B plus delta B multiplied by B plus delta B multiplied by C plus delta C. Those of you who could not attempt this question, that's your V final. Multiply and then go for this delta V upon V delta T. This will be called what? Gamma. What is delta V? V final minus V initial. Try to write gamma, and I hope in 30 seconds you can easily figure out. If you can multiply these three and you can neglect all those things which are negligible, then you can easily answer relationship between gamma and alpha. Should not take more than 30 seconds now. Try this and then write down the answer. So this V final is A, B, C, then A delta B A delta C plus this was A, B, C, and then what I did, A delta B, A delta C. And now B delta A, B delta A, B delta C, then A delta C, that is already present, but this term, I think every term is present now. No, there are two terms missing. What are those? The important ones. The other ones are what? Quite negligible. The things we are not interested in. We'll save time. We'll save time this way. Look at this. Delta A into delta B. Delta A, delta B. There are two terms of dx and dy. That's negligible. Similarly, when you go for dx into dy into dz, those things are what? Again negligible. You're getting terms of what? dx, dy, dz. Apart from these terms, you're also getting terms of dx into dy, dy into dz, dz into dx, and dx into dy into dz. We know that these terms are negligible and therefore I will not represent those terms. We'll take only those things which are useful for us. So, how many terms we have got? So we have got A delta B, we have got A delta C, the useful term. We have got delta A multiplied by B, delta A multiplied by B. This delta A multiplied by C, this is missing. Delta A multiplied by C, then this delta B multiplied by C was already present, I think. Delta B multiplied by C, no, it's not there. So let's write down this also. Delta B multiplied by C. So I hope we have got every useful term. I guess we have got every useful term. Now, once you get this V final, we are interested in what? Delta V. If something is wrong in this, then mention this in the comment box. I will just correct that part. If I have repeated something or some part is missing, this delta V is V final minus V initial. Let's save time. This ABC is your V initial. So V final minus V initial. It is already what? A delta B plus A delta C plus B delta A plus B delta C plus C delta A plus C delta B. With A delta B delta C, with B delta A delta C, with C delta A and delta B. Then delta V upon V, delta V upon V is this part whole divided by ABC, the volume thing. A delta B divided by original volume, which is ABC, plus divided by ABC. I'm removing this figure. B delta A divided by ABC plus B delta C and similarly C delta A upon ABC and C delta B upon ABC. A and A cancelled. We have got delta B upon B one by C. Delta C upon C A and A cancelled, 1 upon B, plus B and B gone, delta A upon A, delta A upon A, B and B gone, you get 1 by C, delta C upon C, B and B gone, 1 upon A. I am removing this figure. C and C gone, delta A upon A, CC gone, 1 upon B, plus CC gone, delta B upon B, 1 upon A. So we have got the whole relationship, delta B upon B, 1 upon C. Delta C upon C, 1 upon B. Delta A upon A, 1 upon C. And these terms. Now, when you take all these terms, what ultimately you get, wait a second. We have committed a silly mistake. Nobody told me that. The silly mistake is what? Look at that silly mistake. A, B, C. And then what I did? I took A and delta B. A and delta B. So when you are taking A and delta B, you're also multiplying it with C. You're also multiplying A delta B, and then that will be multiplied by C. A delta B will also be multiplied by delta C, but since two deltas are present, we are not interested. But we missed what? A into delta B, साथ में क्या रह गया? C. This is creating a problem. So let me write that C over here, that the extra term which we missed, C. Once you write this C, you don't have to worry about the other things. You can find the missing parts very easily. Look, this is delta B and it has what? A and C. This is delta C, it will have what? A and B. This is delta A, it will have C and B. कैसे? देखना. A and delta C. Let's talk about this. A multiplied by delta C. So when you are multiplying A with delta C, you will also multiply it with B. A multiplied by delta C will also be multiplied by delta A, but since two deltas are present, that term is what? Negligible. So by symmetry, you can easily write all the missing links. What are the missing links? Look again. A, C, delta B. So A, B, delta C, C, B, delta A, and then repeat the whole thing. Since this is delta C, B, A. This is delta A, C, B. This is delta B, C, A. So how do you arrive at this delta BC? This is A multiplied by delta B and then multiplied by delta C. I hope this thing is clear, and once this thing is clear, it also tells us that we are committing another silly mistake. We are repeating the things twice. इससे अच्छा मल्टीप्लाई कर लिया होता. My fault. Shortcut करने की प्रोसेस में we are in fact wasting time. So I hope you are getting the calculation part. You can always multiply each and every term and then you can go for the simplification thing. I hope you can multiply these things, and if I am not able to multiply properly, then आपको पता है कि सर को मल्टीप्लिकेशन आता होगा, वो जस्ट कभी कभी हो जाता है ऐसा. So I hope the things which are repeating themselves are what? Look at the term of delta C. AB, delta C, AB. So we have taken things, we have repeated these things twice, everything, every delta term we have repeated. And how come I repeated that thing? What I did, I multiply A with delta B. But this A delta B ultimately will be multiplied by C also. And when I was calculating, I took A delta B separately and then I took C delta B separately. No, this is A multiplied by delta B and C. So remember, we have committed a silly mistake which is not difficult to understand. So do what? Remove all those terms which are extra. Remove all those terms which are extra. What are the terms extra? Delta B, delta C, delta A. This is extra, this is extra, this is extra. They are not negligible, these are extra terms. समझ में आ रहा होगा भाई. A C delta B, A B delta C, C B delta A. ये रिपीट हो गया delta C. सेम A B delta C. ये रिपीट हुआ है C B delta A. CB delta A, repetition. So you can remove all those terms. Once you remove all those terms which have been repeated, and you take care also of this AC part. So the first thing, this was not A, this was basically AC. So AC and AC cancelled, and once you get AC and AC cancelled, this is not there. It was creating unnecessary problem. This term was coming unnecessarily. Similarly, this part is what? A into C. So this was A, the second term. What is the second term? AB. This is AB. AB and AB cancel. You're left with delta C. This is not coming. Hopefully दिख रहा होगा. सवाल लेना कैलकुलेशन का, कोई बड़ी चीज नहीं है. Third is this delta A CB. So you multiply with C, CB, CB gone, CB, CB gone, delta A upon A. So you got delta A upon A, and this one upon C is gone, and this was extra, this was extra, this was extra, remove, remove, remove. That means you don't have to write these terms. So we are left with this, and in just around 1 minute, if you go properly, then you can see that we have found the result. Delta V upon V, change in length upon length, change in length upon length, change in length upon length, also divide by delta T, and finally it looks like this. This is all delta B upon B, delta T, delta C upon C, delta T, plus delta A upon A, delta T. What is this? Gamma. What are these? Alpha, 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 giving us gamma equals to 3 alpha. I hope समझ में आया होगा हमने क्या कहाँ गड़बड़ की हुई है. So those of you who could not form this gamma 3 alpha, if they have understood the approach, also the silly mistakes which we committed, if you are comfortable with this now, then write down yes in the comment box. And if you have any confusion because of all these things, then tell me. Well, let me give you an easier proof for cube. For this, definitely we have to follow the whole technique of multiplying and then dividing this. With a cube, we can save time also using a simple concept of binomial and all. So look at this example of cube. Yeah, every approach is same. If you have a cube, side length is what? L. Temperature is T, and then temperature increases, side length also increases. So what is delta L upon L delta T? This is your alpha. And we need to find what? We need to find delta V upon V delta T. That will be the gamma part. What is V initial? V initial is L cube. Approach same hai, but we can save time with cube. What is V final? V final is L plus delta L cube. Increase the temperature, increase the length, and then take the cube. Now we can easily take cube of this using this technique. Take L out. If you take L out, it will be L cube. And then inside it's 1 plus delta L upon L cube. So, once I write 1 plus delta L upon L cube, this is coming from binomial. If we have 1 plus x to the power n type of thing, then this can be approximated with 1 plus nx, provided x is much smaller than 1. Not always, only if this term is small as compared to 1. So delta L, small change in the length, divided by L. This thing is much smaller than 1. Delta L is small, and then you're dividing that by L also, becoming much smaller. So what I can do is I can write L cube 1 plus n inside 3 delta L upon L. What is this? This is L cube. This is what V final. So what we have got V final, L cube inside. What is L cube? V initial. This is V final. L cube is what? L initial plus 3 delta L upon L. L cube into 3 delta L upon L. Shift V final minus V initial becomes what? Delta V. L cube V initial 3 delta L upon L. I hope you can see the final answer. This is delta V divided by V initial is coming 3 times delta L upon L. Divide by delta T on both sides, and you got what? You got gamma. Divide both sides by delta T, and you get what? Gamma is 3 times alpha. We can expect something like this in your school examination, because it will be much easier in terms of cube using this concept of binomial. Tell me, are you comfortable with this one? Yes or no? Tell me, for a circular ring, what should be the concept for ring? Coefficient of linear expansion or coefficient of surface expansion? How can you find change in its dimensions? I'm asking you, for a ring, if we have to investigate what happens after you raise the temperature by delta T, so what should be the approach? Should we go for alpha or should we go for beta? What do you suggest? Write down fast in the comment box. Well, that's what I expected from you, that you will say beta. But no, it's not a disc. It's not a disc. It is what? A ring. So if it's a ring and you raise the temperature, then first of all its circumference is going to increase. There is no material over here. It's not a disc. If you have a disc, then this place is also occupied. It's a ring. Ring means only one length. Area wise nothing is present, and therefore we need to use concept of alpha. Now let me repeat the same thing in this form. I give you a cubical box. Look, cubical box. What is a box? Box is something which is empty inside. So with a cubical box, what will you use? Write down fast in the comment box. Alpha, beta or gamma. This was a solid cube. But now I am giving you a cubical box. So the cubical box, what would you take? Alpha, beta or gamma? Write down fast. Good. What is a box? Box is something which has surface. So if you increase the temperature, surface area is going to increase. If surface area is going to increase, then for a cubical box, it's a box. For a box, we are increasing the surface area, and therefore we will not choose gamma, we will go for beta. Let me give you a visualization of this. Suppose you have a box of iron sheets, iron and thin sheets of iron, and you make a box type of thing. And then you have a solid iron piece, same size and dimensions. Box with iron sheets of length L, another solid cube of iron, same material. If you increase the temperature, will you get same volume expansion? Yes or no? Write down fast in the comment box. This is something which you can also feel yourself. I've given you something which is just made of thin sheets, and the other thing is a complete volume. They have both same dimensions. If you are going to use the concept of volume expansion for this, in this also volume expansion is present, but Basically, surface area is increasing. In this, all the molecules are present deep inside the volume. In this, molecules which are going to move heavily once you increase the temperature are only present over the surface. So when you change the temperature and I ask you that are they going to suffer same amount of volume change, and I'm asking you yes or no. And good, the answer is what? No, they will not have same type of thing. So if somebody starts using what? If somebody starts using concept of that gamma for this box, which only has surfaces present, surface, I've drawn this line to show that only surface is present, then for this and this, your delta V will not be same. For this, delta V solid, delta V hollow, which one will be greater? Same material, same side length. What do you think? Which will be more? Solid or hollow? Fast. Last thing for today's lecture. Which do you think will be more? Solid, change in volume for the solid, or change in volume for the hollow? What is your intuition? Good. Change in volume for the solid will be more, because less number of molecules or atoms are present here, and you can see it's a complete solid, and therefore volume expansion will be more. Note down this much and then you can leave. Thank you very much. This last example, I have told you that we have got a box which is made of thin sheets like a simple sheet of paper. So you have a sheet of paper and then you fold it. Let's say a cylinder. It will be easier for me to explain this way. So you fold a sheet and you make a cylinder. Now this cylinder is a three-dimensional thing. It's a three-dimensional thing. It occupies some volume. If I increase the temperature, definitely volume is going to increase. For that volume change, if you start using concept of beta, concept of gamma, then you will not get the correct result. You can understand it this way. You have got a solid which is not entirely made up of same material. This is a solid whose outer surface is of, let's say, steel, iron, but the inner portion is what? Air. So when you are heating this thing and you are using gamma of steel, then you will never get the correct result. Now imagine the whole thing is made up of what? Solid steel. If it's solid steel, that means entire volume is identical. Increase the temperature. Now use the concept of gamma of steel. Hollow cylinder, increase the temperature, volume will increase, but you know that the inner portion is basically what? Air. So we can say that they both are not same. So how will you find change in volume? Go for what? Change in the side length of the cube, the cylinder in this case, and then based on that change in side length. What are the change in side length? You've got what? You've got something like this, which is basically what? A sheet. Open it, increase the temperature. Now you will be using concept of what? For a sheet, you will be using concept of what? Beta. Find out change in both sides, fold it, and now find the volume. That's how you can find change in volume for something like this. Are you comfortable with this? Yes or no? Fast. Good.